Ever wondered how your computer talks to someone else's halfway around the world? Welcome to the fascinating world of internetworking, the invisible threads that weave together our digital communications. This marvel connects multiple diverse networks into a single expansive web, which we know and use as the internet. It's the reason your email reaches its destination across oceans and your favorite global news updates pop up in mere seconds. Stay tuned as we unravel the components that make this global conversation possible. Imagine the internet as a busy highway. Internetworking devices are the traffic lights and signs. Picture a world where data packets are vehicles, each having its own origin and a specific destination across vast digital landscapes. At the heart of this bustling data traffic are routers, the most quintessential of internetworking devices. These routers have the critical task of forwarding these data packets between different networks. How do they achieve this? By meticulously analyzing the IP addresses tagged on each packet, ensuring each one is sent along the most efficient route possible. But routers aren't the only key players here. Enter switches, the unsung heroes working within individual networks. They manage the flow of data packets based on MAC addresses, directing them to the correct device within a local network. And let's not forget other devices like modems and access points, each playing a pivotal role in maintaining the seamless flow of internet traffic. These devices ensure your data arrives at the right destination, but how do they know where to send it? To communicate effectively, everyone needs to speak the same language. In the realm of internetworking, this language is articulated through protocols, the sets of rules that manage how data is transmitted and received across different networks. Imagine protocols as the grammar of a language, structuring communication so that it is universally understood regardless of the system's origin. At the heart of these protocols is TCP/IP, or Transmission Control Protocol, Internet Protocol. This suite is not just foundational, it's the backbone of internet communication, enabling disparate networks to interconnect seamlessly. TCP handles the data preparation for the internet, breaking it down into packets, while IP takes charge of sending and addressing these packets to their correct destinations. These protocols ensure that a message sent from a computer in Tokyo can be understood and responded to by a server in London, maintaining the integrity and efficiency of data exchange. Through this standardized protocol suite, devices across the globe don't merely talk, they engage in complex interactions based on mutual understanding. With protocols, devices don't just talk, they understand each other. Every device on the internet has a unique identity. Imagine walking through a bustling city where every building has an address. In the world of internetworking, this is how devices communicate with each other. Each device connected to a network, whether it's a smartphone, a laptop, or even a smart fridge, is assigned a unique identifier known as an IP address. This address is crucial because it ensures that information sent across the internet finds its way to the right destination. IP addresses come in two versions, IPv4 and IPv6. IPv4 uses 32-bit numbers, typically shown in decimal format like 192.0.2.1. However, due to the explosion in the number of devices online, IPv4 addresses are running out. Enter IPv6, which uses 128-bit numbers to accommodate an exponentially larger number of devices, ensuring every grain of sand on Earth could theoretically have its own address. But knowing the address is just the start. Finding the best route is key. Finding the best path in a complex network is no small feat. Routing, a core component of internetworking, is what makes your email, your video stream, or even your simple web search zip across the globe from one computer to another. It's all about finding the most efficient route for data packets to travel through an intricate web of networks. Imagine a letter needing to find its way from a remote village in Scotland to a bustling street in Tokyo. Routers act as the postmasters of the digital world. They examine the address on each data packet and consult their routing tables. These tables are rich with information about which paths to take and which to avoid, much like a seasoned traveler's map filled with notes and shortcuts. Routing algorithms are the brains behind the operation. They dynamically calculate the best paths, considering factors like network congestion and the cost of travel paths. This ensures that data packets take the most efficient route possible. Efficient routing reduces congestion and speeds up your internet experience. While routers handle traffic between networks, switches manage the traffic within a network. Let's dive into the world of switches, the unsung heroes that keep your local network running smoothly. Inside every network, vast amounts of data packets are zipping around, trying to reach the right destination. This is where switches step in. They operate primarily using media access control, or MAC addresses, which are unique identifiers assigned to each device on a network. Imagine a busy city intersection, but instead of cars, you have data packets. A switch acts like an intelligent traffic signal, directing these packets to the correct device within the network efficiently. It examines the MAC address contained in the incoming packet, quickly decides which output port to send it to, ensuring that the packet reaches its intended device and not just any device on the network. This not only speeds up data transmission, but also significantly reduces the chance of a collision of data on your network. Switches keep your internal network organized and efficient. How are different networks physically connected? This is where the magic of interconnection technologies comes into play. Let's delve into some of the key players: Ethernet, Wi-Fi, and fiber optics. Ethernet is one of the oldest and most widely used methods. It's like the reliable old friend who ensures that data packets are delivered efficiently across physical cables. Ethernet is particularly prevalent in local area networks where high speed and stable connections are necessary. Moving to a more invisible but ubiquitous technology, we have Wi-Fi. Imagine Wi-Fi as a kind of digital airwave, floating through the environment, connecting devices without the need for physical cables. It's perfect for providing flexible access within homes and businesses, allowing mobility and ease of connection. Then there's the speed champion fiber optics. Fiber optic cables use light to transmit data over long distances at speeds that can seem almost like science fiction. They are crucial for the backbone of the internet, connecting continents and handling massive amounts of data with minimal loss. These technologies form the physical backbone of the internet. The structure of a network greatly impacts its performance. Imagine designing the blueprint of a vast city. Just as the layout of streets and highways affects traffic flow, the structure of a network, or its topology, influences data flow and network efficiency. Let's explore a few key topologies. Firstly, the star topology. Here, all devices are connected to a central node, usually a network switch or a hub. This setup enhances the network's reliability because if one link fails, only that connection is affected, not the entire network. It's akin to having a backup road when one is closed. Next, the mesh topology. Think of it as a network where every device is interlinked with every other device. This redundancy ensures that even if one or more connections go down, data can still find an alternative route. This is ideal for ensuring maximum uptime, but can be complex and costly to implement. Lastly, the hybrid topology, a combination of two or more different topologies, allows for flexibility and scalability. It's tailored to meet specific needs and can adapt as those needs change. The right topology can make or break a network's performance. As our networks connect, so do our vulnerabilities. In the vast web of internetworking, security is not just an option, it's an absolute necessity. Imagine data as a valuable asset, constantly in transit across multiple networks. The risks? They are as diverse as interception, unauthorized access, and even cyber attacks. To guard against these threats, a robust arsenal of security measures is deployed. Firewalls stand as vigilant gatekeepers, monitoring incoming and outgoing traffic to block malicious data. They serve as the first line of defense, ensuring that only legitimate traffic passes through. Encryption transforms readable data into a secure code, shielding sensitive information from prying eyes during its journey across networks. Even if intercepted, encrypted data remains a locked treasure chest without the right key. Virtual private networks, or VPNs, create secure pathways for data to travel. They extend a private network across a public network, ensuring that data remains private and secure, even when sent across less secure channels. Secure internetworking is crucial for safe, reliable communication. We've traveled through the intricate world of internetworking, from routers that guide our data across different networks to the foundational protocols like TCP/IP that ensure our messages are understood. Each component plays a vital role. It's the addressing system that assigns a unique identity to every device, allowing them to be pinpointed in the vast digital cosmos. Routing algorithms calculate the most efficient paths for our data, ensuring swift and reliable communication. Switches take charge within networks, directing data packets based on MAC addresses, while various interconnection technologies physically bind these networks together. Our journey has shown us the diverse topologies that dictate how networks are structured and interconnected, from star to mesh and beyond. And let's not forget the fortress of security measures, firewalls, encryption, VPNs, guarding our data against threats, ensuring a safe passage in the digital realm. Thanks to internetworking, the world is just a click away. Imagine what we'll connect next.